Hey guys, I hope that I'm live right now. If you guys are able to listen me properly, as well as there's no issues with the audio or the video, please let me know. Hello everyone, I hope that I'm live right now, guys. If you guys are able to listen me properly, as well as there's no issues with the audio or the video, please let me know. No issues whatsoever. Okay, great guys. Awesome, awesome. So today we are at the final stage of our human versus AI, right? The final stage of our code, human versus AI. Okay, so let's make sure that we are able to do that today. Okay, so let me open up your chat section on my screen right now, as well as my code on the right hand side. I hope that you guys are able to see my screen, right? I hope that you guys are able to see my screen, or am I the only one who's saying that you guys are able to see my screen or not, right? Great. So did you guys code everything that we have done up till this point of time? I told you guys to code everything that we have done up till this point of time. Did you guys do everything that we coded up till this point of time, guys? Please let me know. See, guys, again and again, I'm telling you guys, if you're not coding, this session is absolutely of no help to you guys. Okay, you need to code it, you need to practice it, otherwise you're just wasting your time right over here. Try to make sure that whatever you're learning right over here, you guys are actually practicing it, you guys are coding it right over there. Okay, otherwise it is of no use. Okay, coming here, being in this particular camp, listening to me, wasting your time, do not do that. Just, if you want, I'll give you some great advices on which anime to watch, which movies to watch, which TV series to watch. I'll help you guys out with that as well. Okay, but if you're coming right over here, make sure that you guys are coming here to learn. Okay, are you guys able to understand this? Please let me know. Are you guys able to understand this, guys? Please let me know. Good. So let's continue with our code, guys. Right now we'll be coding our computer's turn, guys. Okay. We named a function right over here, right? While creating the entire gameplay, that is comp turn. We're going to code this particular session first. Okay. That is this particular function first. The reason for that is very simple. We want to write the code what happens when it is the computer's turn. Okay, so let's do that. Let's do it comp turn. Let us put up it as a def. Okay, def comp turn. Okay, again, of course, it will take in the board. That is the list board, BOARD. I'm very sorry for that. Board as the input right over here. And then we can start off with writing our code itself, guys. Okay, post input enter x position from dot to dot. Instead of writing this, can we also write post input? Yes, of course you can do that. I'm writing it in two separate lines because to make sure that students are able to understand what I'm doing right over there. Okay, I want to make the code as simple as possible for beginners to understand as well. There is a name error in x is equals to analyze board. It shouldn't be the case. No, there is no kind of error right over here. Please look into your indentation. I think so there's some problem with the indentation itself, right? Okay, great. So let's start coding. It's the last day of AI. Absolutely not. AI is not something that I'm going to stop so soon. We'll be having more number of boot camps, we'll be having more number of classes, and a lot more that we'll be studying throughout the entire thing itself. Okay, if you guys are participating in the training and internship program as well, right over there, there's a lot more number of AI algorithms, games that you will be able to write and make, and even some chat GPT stuff that you will be able to make right over there as well. No issues in that. Let's start and get ready with our code, guys. Okay. So the first thing that we are going to do right now is that we are first going to specify the current position. Okay. Current position as the current value that we want to assign. See, our main aim is to find out which particular. So let's assume this. Let us go back to our board itself, right? We want to figure out if this is the current state of the board. Okay, I am the first player. I am a human being. I wrote my X right over here. Now it is the computer's turn. Where should the computer place its O? What would the computer do, right? The computer will go to various different positions. It will try to mark one X right over here, right? It will mark a 0 right over here. It will check whether this particular step was the best step for me or not. Okay, this particular step is the best step for me or not, guys. Okay, similar to that, I will mark a 0 right over here. Is this particular step the best step for the computer or not? And so on and so forth. It needs to identify which step is the best for it. Are you guys able to understand this? Please let me know. It needs to identify which step is the best step for it. Right, guys? Try to think about it. So what will it do? For the min-max algorithm to actually work, it will choose every single box that is there on the board which is currently available. For example, let's assume that these are the two X's that I put right over here. Okay, these are the two X's that are there on the board. Whatever positions are currently empty, whatever positions that are currently empty on the board, let's assume this is an empty position, then this is an empty position, then this is an empty position, then this is the 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 empty position. For each one of the empty positions that are there available on the board, it will check whether which particular position is giving me the most likely outcome to win. And then whatever position is able to get it the most likely outcome to win, that particular position will be the one it will be placing the 0 at, right? It will be placing the O at that particular position itself. Am I right or wrong, guys? Are you guys able to understand this? Please let me know. The first thing that we have to find out is the position. Where am I going to place my O? Where am I on this particular board going to place my O in such a way from I'm an AI, I'm a computer itself. Okay, so where should I place my O right over here so that I'm able to get the best possible outcome? Initially, I don't know which particular position that should be. My final answer, I will place it at every single position. I place it at every single position. I will check which particular position is the best. And the final answer, whatever will come, whatever position that comes with the best possible outcome, that will be my final position. That will be my final position itself, right, guys? Whatever is the best possible outcome itself, right? So for that, I will assign the position in the starting as -1. Does -1 exist on our board right now? Does -1 position exist on our board list itself? And guys, let me know that. Think about it very carefully. Does -1 index position is present on our board, guys, anywhere on our board? No, right? Our board has indexes from 0. -1 does not exist. -1 does not exist, right? So initially I am placing my position as -1 that does not exist itself. I'm initializing my position as -1. The next thing that I have to do is I have to go to every single position. I will have a for loop for I in range 0, 9, right? For I in range 0, 9, I will go to every single position if that is empty, right? If board I is equals to 0, that is an empty position itself. That is, there is no x or 0 already present right over there. I will first assign that, okay, first I will come up at this position. Okay, here at I is equals to 0, I already have an x. That means board I is equals to -1. It is not equal to 0. So I cannot go into this. I'll go into the next particular format itself. That is I is equals to 1. In I is equals to 1, board I is equals to 0, right? There is nothing right over here. In board I, when I is equals to 1, there is nothing right over here, right guys? Please let me know. Good. So in that particular case, we are going to put up our first 0 right over here. So we'll write if board I is equals to 0, we'll put up board, just a second, board I is equals to 1, because 0 is represented by 1, right? The computer's turn is represented by 1 itself. Are you guys able to understand it? Please let me know. We are putting that. Okay, first let us put our 0 right over here. Okay, let us put our 0 right over here. Then using the min-max algorithm, itself, we have to find whether putting our 0 right over here gives us the best value. For those guys who attended the session in which I taught you guys about the intuition behind min-max algorithm itself, those who have not attended that, you will not be able to understand it. Those who have attended it, you will be able to understand that this particular game will cost us multiple different methods itself. That okay, X can then put his right over here, then that will be one game plan, and there will be another game plan, and so on and so forth. And then we will be propagating the values that we are having at the very end upwards and getting a final value itself, that this is the value that we are getting, that is the best possible value in that particular step itself. You guys remember that? Please let me know. Do you guys remember that? Please let me know. In the min-max tree that we saw right over there, it will see every single possibility. After that, it will create the entire tree, all the possible moves after I put a 0 right over here. And then it will propagate the values at the terminal, at the ends of the tree itself, upwards, and find out what is the best value for that. What is the value? What is the final value? If I take this step, what is the best value that I'm able to get, right? So initially that value, I'm placing it up as -2. The greater the value is, the better you will be able to, chances of you winning. The greater the value is, the better is your chances of winning. Now, why I have taken -2 right over here, we will only be able to understand once we implement the min-max algorithm. We will not be able to understand why I have taken -2 right now. We will only be able to understand this after I have written the code for min-max as well. For right now, let's assume, okay, for right now, let's assume that the value, initial value, the initialization of value I have taken up is -2. Why -2? We'll understand once we have written the code for min-max. Okay. The next thing that I will be doing is I will calculate the score for this particular step. Whatever step that I've taken, I place the 0 at index 1. Whatever step that I've done right over here, I will calculate the score of that. Score would be equal to minus of, okay, this, why minus is there, what is I'm writing right over here, this will, you will be able to understand once we have written the min-max code. Okay, right now you will not be able to understand, but try to figure out that the score basically means. Okay, the score basically means the value, the score, the value that I'm able to get by playing this particular step using min max. That is what I'm calculating right over here. And then the min max algorithm, the algorithm that we are going to write. Okay, the min max algorithm, the algorithm that we are going to write itself, guys. Okay, if the score is greater than the value that is there, if the score is greater than the value that is there, in that particular case we need to increase our value, right? That is the better step, right? Not playing any step, it is better than that itself. That is the value. Now the value would be equal to score, because this score is better than our previous value. This score is better than my I think so. I'm hiding the thing that I'm writing right over here. Let me just remove myself from the screen itself for a few seconds. Okay, so this score is better than my previous value, right, guys? So we need to change our value to the new score that we are able to get, because this step is better than the previous step that we have taken. This step is better than the previous step that we have taken, because the min max algorithm is saying so. Because the min max algorithm is saying so. And because this step is better, right now for us, this is the step that we should take. So our P position will also be increased to the value of I, because this is the better step. This is the better step as of this particular point of time. Now we'll do this for every single position that is there on the board. Next, we'll change in the for loop, the value will change to 2, right? We'll place our 0 right over here. We'll change our 0. Now the value of I is equal to 2. We'll place our 0 right over here itself. That is at the index 2. Then we'll again go into the code. We'll put our 0 right over there. So board I is equals to 1. So we have put our 0 right over there, guys. We'll check if the new score, by doing this particular step, is the new score returned to us via the min-max algorithm. Is what is the score? Okay, if I do this particular step, if I place an O at this particular location, is my scoring, what is my score? Okay, what is the probability that I'm able to win? If that score is greater than, the value, the previous value, whatever step that it took when I was equal to 1, when the previous 0 that I put right over there is putting a 0 at the second particular position, is it better than putting a 0 at the first particular position? Is the score higher than my previous value itself? In that case, my new value would be the new score that I'm able to get. That is the highest score that I can achieve. My aim is to find at which particular position I'm able to get the highest score possible. That is my aim. And that is how at the end I'm able to decide which position was the best with the highest score. Which position was the best with the highest score. And that particular position is where I will decide that this is the position I want to put my 0 on. Maybe it is the 5th particular position. Maybe it is the 9th position or the 8th position that is returning to me the highest score possible. That is the position that I will be able to work upon. Assume this is returning to me a score of 0. This is returning to me a score of 1. This is returning to me a score of 5. This is returning to me a score of 2. This is returning to me a score of 6. This is returning to me a score of 3. This is returning to me a score of 9. That is the highest score possible. This is where I will choose that, okay, this is where I want to put my particular thing about. Think about it in such a way that there is a particular person, okay? This is a particular person wearing a magic hat. Let us put it up as a particular thing that you guys are able to relate to. I know a lot of coding has happened. Let me explain to you guys in noob manner. Okay, so this is a particular person, a very wise person. Okay, he has mustache, he has beard. He is Gandalf. Okay, he's the Gandalf from Lords of Rings. He's a very wise person. He can tell you what is going to happen in your future. Now you are a particular person who likes betting. Okay. You are a particular person who likes betting money on stuff. So there are various different horses. You are betting on different horses itself. Okay. There are currently, so somebody else, you want to beat somebody else itself. Okay. So there are 9 horses currently. Okay. Let me draw those horses. I'll just copy paste it. The 9 horses right over here, guys. Okay, let's put up a tail as well. So that it looks like a particular person, a fat person shitting right over there. But I hope that you guys are able to understand. This is the drawing of a horse itself, right? So you are betting on this particular horse. You are having this wise sage. Okay, you're having this wise sage that is able to tell you guys, okay, that which particular horse has the highest probability of winning. Which particular horse has the highest probability of winning. Now, the lowest possibility of a horse winning is -2. Let's assume that. The lowest probability of a horse winning is -2. Lowest probability. There's nothing lower than that. It cannot exist itself. Okay? So what would you do? You'll come to Gandalf. You'll come to the first horse. You'll come to the first horse. You'll ask Gandalf that Gandalf, is this particular horse? What is the probability? What the probability? Now this Gandalf is nothing else but your min-max algorithm. This Gandalf is nothing else but a like he's telling you a probability. Okay, that is your min-max algorithm itself. You are asking it that Gandalf, which for this horse number 1, what is the probability that it is going to win? Gandalf tells you that the probability of this horse winning is 0. The probability of the first horse winning is 0. Now you have decided that you're not going to bet on any horses. Initially, you decided you're not going to bet on any horses. So let us assume that we create a variable called as POS. That is that my probability of betting on a horse right now is -1. Okay, this is the horse that I'm going to bet. There's no horse called as -1. There's no horse called as -1. So initially you say that, okay, -1 is the horse that I'm going to bet on it itself, guys. Okay. So right over here, what will happen is you'll go to Gandalf, you'll say that, okay, what is the probability of the first horse winning? He says it is 0. Okay. So you're like, yes, 0 is greater than 2, right? Is 0 greater than 2 or not, guys? Please let me know. The score of the horse 1 is 0. Is it greater than your -2? That is the lowest that is there. That means it is great. It is better to bet on it. Instead of betting on nothing, it is better to bet on something that has a greater score, right? So we'll increase the POS to 1. That is, I will bet on the first horse. And the new highest value and the new highest score of the current horse is 0, right? The new highest score of this horse is 0. Now your new score of the current horse that you're betting upon is 0. If any other horse has a higher score than 0, only then you will be betting on it. You will be changing your bet from the first horse to some other horse. Only if some other horse has a higher score than that. Yes, you come to the second particular horse. You come to the second particular horse. You are again like, oh my great Gandalf, you let me know whether this is the horse that I should be betting upon. What is the score of this particular horse? What is the probability of this particular horse winning? Gandalf does his magic and tells you that the probability of this particular horse is -1. The probability of this particular horse to win is -1 itself. Now, is -1 greater than 0? Is -1 greater than 0, guys? Currently, you are betting on the first horse which has a score of 0. Is -1 greater than 0 itself, guys? No, right? So, should you change Should you change your bet from the horse 1 to horse 2? No, right? You shouldn't change. You shouldn't change your bet from horse 1 to horse 2, right, guys? So you will remain at the same bet. I will not going to bet on horse 2. I'm going to bet on horse 1. It has greater probability. It has greater score of winning itself. You come to the third horse. Again, you ask Gandalf. Gandalf say that the probability of it winning, the score of it winning is 5. 5 is greater than 0. Currently, you are having the score as 0, right? 5 is greater than 0. So we'll again change your current score. The current bet will be changing it, and the current highest score is 5. The current highest score is 5, and you will be changing your bet from the first horse to the third horse, right? You'll be changing your bet from the first horse to the third horse because it has greater score. Let's assume the rest of the horses as like score of -2. Somebody has a score of -1, 1, 3, 2, 4. But changing all these horses itself, the highest score always remained at the horse of 3. So that is the horse that you're going to bet upon. You have to bet on one of the horses. You cannot choose on not betting on any of the horses. You have to choose one of the horses to bet upon. That will be the horse number 3 itself. And that will be the final position wherein you want to lock in that, okay, I want to bet on the horse 3 itself, right? That is what we are trying to do inside of the code as well. Every time we are checking for a particular board number, if I play this, I'm asking from Gandalf, I'm asking from min-max algorithm itself, what is the score? If it is greater than my already existing value itself, in that case, I'm going to change my value. The current score, the highest score, I'm going to change my position where I should be putting my O right over there. That is what you are doing right over here inside of the code as well, guys. That is what you are going to do inside of the code. If you go back to the code itself, and we'll start writing our code as well, guys. So as soon as I'm starting to write our code, maybe you guys are able to understand what I'm writing. Okay. So we'll start with the utmost basics itself, guys. We'll start with the utmost basic itself. We want to first initialize our current position. So initially we'll initialize it as -1, which does not exist itself. We'll put up a value. Okay. We'll put up a value as -2. That is the lowest value. Why is it the lowest value? We'll be able to understand once we code the min-max algorithm itself. For I in range 0 to 9, we want to check for every single position what is our score. But only in that case if it is available. If that horse has not already been betted upon. If that horse has already, somebody else has already bet upon the horse, you cannot bet on it again. You have to bet on something else. So we will check if board, okay, I is equals to 0. That is, that particular position is currently available for us to bet upon. We'll first bet upon it. We'll check board I is equals to 1. We'll bet upon it. We'll check our current score of that particular bet. SCORE score is equals to minus. We'll be writing this particular code, guys. Why it is minus? Why is it min-max? What is we are giving it as input? We'll look at that when we'll be coding the min-max algorithm. Right now, just assume that this is a black box. This is the wizard Gandalf right over here. Okay. Min-max. Okay. And we'll call it as min-max, and you guys can call it as mini-max as well, whatever you want to call it as. Board, comma, -1. These are the inputs that I'm going to give it to it. What are these inputs? Why are we giving this input? We'll be looking at, we'll be coding the min-max algorithm itself. Now we'll be checking board. We want to erase it as well. Right now, we are not sure that we are going to run. We're not sure that this is the step that we are going to take, right? We're just putting it as 1 so that our min-max board, the current board, the new board, if we do that step, the new board that is going to go to our Gandalf, it should know that, okay, this is the step that you have taken. Once the score is given back to you, you don't know if you're really going to play that step. You are currently checking every single step. So you need to erase that step as well, right? You did that step, you check the score. Now you don't know if that is the highest score or not. You have to check for every single step, and then only you will know that whether that was the highest step or not. So when you are going to the next step, we need to erase that step as well. So board I is equals to 0. That is, currently we have not placed anything on the board. We have got the value, we have erased everything from the board. The original board is still with us. Okay. That step we have erased it. If score is greater than the value, okay, if score is greater than the value, we are changing our value, we are updating the value that, okay, this is the highest value that we are having. And position as well, we are currently updating the position that this is the horse that we want to bet upon. Currently, we want to bet upon this horse. Once you've gone through every single output, once you've gone through every single, we have 0, you kept the 0, you checked the score, you removed the 0, you checked if this is the score that is highest, if it is not, it's fine, if it is highest, you update the value itself, and so on and so forth, right? Amir Hamza is asking, why is the range 0 to 9, what not 0 to 8? For that, you have to attend the classes every single day. Almost 3 days I've explained why it is 0 to 9. How does range function work? You have to attend it every single day, otherwise you will not be able to understand it. I've already explained it to you guys again and again. Okay, so whatever is the final output, okay, whatever is the final output for you guys, that is the final position that has the highest score, that you have to use right now, right? That you will have to use right now. Are you guys able to understand this? Please let me know. Whatever is the final particular position that you are able to get, that this is the particular thing with the highest. This is the particular position with the highest score. That is, you will be able to get only after running all the particular steps, right? All the horses you will be able to bet, and then you will get that, okay, this is the horse that I want to bet right over here, right? So you will be putting up BOARD board, okay? POS is equals to 1. This is where I will be placing my bet upon. This is the place. This is the position where I will be finalizing, and I want to place my O right over here. The AI, the computer wants to place its O right over there. This is the horse I want to finally bet upon. Okay. Are you guys able to understand this? Please let me know, guys. So why is that for multiplayer games, position 1 always wins? Inspect whether the player is playing first or not. I'm not able to understand it, but every single board will get printed. So see who is winning, and you will be able to understand it from right over there, right? Next thing that we have to do is we have to code this wizard. We have coded our computer's turn, that is taking advice from this wizard itself. But right now we need to code this wizard as of this particular point of time. We need to code this wizard right over here. We'll start coding the wizard itself. So now we are coding the actual AI. Now we are actually coding the AI. We are implementing the min-max algorithm. We are implementing the min-max algorithm right now. This is the actual AI. All the code that I have written up till this point of time, that leads to this final answer itself, guys. That leads to this final answer for us. Def min max. Now, as you were able to see right over there, this min-max algorithm, right? This min-max algorithm takes in 2 inputs, the board and then -1 right over here. We know what is the board, right? So why is there a minus in front of min-max? That is negative. Negative, whatever value that min-max is returning, we're taking the negative of it. Why is that the negative? We'll be able to understand once we implement the min-max algorithm. Okay, step by step. Right over here, you guys are able to see that we are having board, so we know what board is, right? So just write board first of all, right? But what is this -1? What is this -1, guys? So could you guys let me know? The computer, the AI is using 0 right over there, right? The AI, the step for AI is by doing 0, by putting 0. What is the value that we have assigned for 0, guys? What is the value that we have assigned for the O? X and O, what is the value that we have assigned for O itself? We have assigned -1 for O. Guys, we have assigned +1 for O. X is -1, O is +1. We put O right over here. Board I is equals to 1. That is where we are putting O. Board POS is equals to 1. That is where we are putting O for the computer itself. +1 is for O. Right over here, we are putting up -1 because we are telling min-max that O has done its task. Right now, it is the chance. The current player who's going to play is the -1 player. That is, right now, I want to put an X on my board. What are the different possibilities that will happen if X puts its own, like everywhere, it will check it for it. So this is the player, the current player who is going to put his task. It can be X, it can be 0, but for this particular purpose, it is X, that is -1. Okay, so this is the player. Okay, which player is currently playing his turn itself? Which player is currently playing his turn? Next thing that we are going to see is if somebody has already won. If the computer made its turn and somebody already won right over there, you need to just return who won. You don't need to return anything else, right? You just need to tell that, okay, this player has won right over there. You're going to write X is equals to analyze. Let me just copy it from there so that I don't make a spelling mistake. X is equals to analyze board. Okay. And then BOARD board, to analyze the board. This will give us if somebody has won. So if somebody has won, that means X will return a value that is not equal to 0, right? If somebody has already won, X will return the value that somebody has already won right over there. Right or wrong, guys? Please let me know. So if somebody has won right over there, what does X return, guys? If somebody has already won right over there, what does X return, guys? Analyze board. What will analyze board return in the case that somebody has already won? It will return the particular person who has won, right? If 1 has won, then it will return 1. If -1 has won, it will return -1 itself, right? Now think about it. The last particular step that was taken was by X. The last particular step that was taken was by X itself. So if we are doing an analyze step right over here, then in that particular case, the answer should be -1 most likely, because, sorry, would be, sorry, I'm so sorry. The last particular step that was taken was by the computer itself, right? I'm very sorry for it. The last particular step that was taken was by the computer itself, right? So in that particular case, you will be getting 1 as your output, because if somebody won, it will most likely be 0 itself, because he was the person who did the last particular step, right? Are you guys able to understand this? Please let me know. So if I return from right over here, okay, if I return X right over here, guys, I'm returning X, that, okay, if analyze board is giving me the particular person who has won the game, right? It will give me the value of the person who has won the game. It will give me either -1 or +1 if somebody has won. Okay, and that is being returned. I'm returning X right over here, that this particular person has won. Okay, let's assume that 0 has won. Okay, so in that case, it will be returning 1. So if 1 is getting returning one, right over here, then this will become what? This will become -1 because there's a minus right over here, right? Min max will be replaced by the value of 1, guys. That is the person who has 1. But what is the value that you are able to see right over here? It is -1, right? It is the negation of that. Okay, Shiv Kumar, I will not be entertaining such type of behavior on my channel. If you're not here to study, please leave my class. Think about it in such a way. Let me just, oh shit. Let me just reframe this once again. Whoever won right over here, if it is 1 or -1, if x, let's assume x is 1, analyze board is coming up to be 1, then 1 is not equal to 0. I'll be returning 1 right over here, and this will be replaced by 1. This entire thing will be replaced by 1, but I put a minus in front of it. So now according to this, -1 has 1. So I need to return the negation of that. I have to return the negation of that, right? So that it becomes true. For that particular reason itself, instead of returning x, I'm going to return x multiplied by the current player. To return the right stuff, I'm going to return x multiplied by the current player itself. Instead of just returning x, that is an edge case. If somebody won in the previous test, somebody did something and somebody won right over here, then I will return the negation of that. This is the only place wherein you will be like, you will not be able to understand it, because this is a very, very, very integrate part of the entire algorithm, because this is an edge case. This is a very edge case. If somebody won, what about that particular case itself? After that, I can promise you guys that we are going to write the exact same code from right over here. We're going to use the exact same code from right over here itself. This is an edge case right over here. This is the most difficult part of the AI, to think about it and to implement it. Why not x, negation of x directly? Great question. So because in the previous step and in the current step, think about it in such a way. In the previous step, you are having x who is doing the step, right? It can be x, it can be 0. That is the person who has already done the step itself. In the current step, it will be the next particular step. So if that is x, now 0 turns is there. If that was 0, now x turn is there, right? It is already the negation of it. If x was the particular person who has did the previous step and now you're coming to this particular algorithm, in that particular case, the person who can win right now would be x itself. It cannot be 0. What is the negation of x? That is O. That is the current player. If in the previous step, O was the particular person who did the step, in the current version, only O can win. What is the player? Player will be x. That will be the negation of O, right? So that is the reason why we are using player. Yes, of course, you can do negation of x directly as well. But this explains what you are doing right over here. See, coding and writing a code that it's already explaining itself is an art. Okay. I can write this as negation of x, blah, 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 blah. It will work properly. It will be amazing. Everything will work properly itself. Great. But your code is shit. Writing a code that already explains itself is something that you're looking forward to. And this code is able to explain itself, that why x multiplied by player, because they both are always opposite of it. The current player and the person winning, if somebody is winning, will always be opposite of each other. That is what this particular code is telling you guys. Like I said, this is the most hardest part of this algorithm to understand. Rest, we are going to go down. We are going to copy everything from right over here to here. Everything. I'm not even like changing anything. I'm just going to copy it from right over here. And I'm going to tell my algorithm that do the exact same thing. It is a little bit harder to understand, Suresh Raj Joshi. I am telling you guys that that first step is the step that it is hard to understand, because that is an edge case. Edge cases are something when you will be coding further, doing data structures, algorithms, computer programming, everybody is able to write the normal code. It's the edge cases where your code starts failing. And that is what something that you don't want to do. Okay. Now that you have done that, okay, you have taken up the case of the edge case with wherein somebody won. What about the next thing? Now you need to figure out for every step that O makes. Now you are checking for X itself, right? Now the current player is X, right? O has done a particular step. In the previous, the computer has done a particular step itself. Now it is a chance of the player. But there is no player. The computer itself has to finalize which particular step will be the best for X. Think about it. Right now, what is computer trying to do? It has chosen a particular step. Now it is trying to figure out which particular step will the user take. It has no idea what the user is going to do. Trying to figure out which particular step will the user take. What will it do? It will now act as the user. It will now act as the user itself. Now, as the user, it will put X's at every other positions and check the score of it and figure out which particular score is the highest, and it will, which is the highest probability for that particular user to win. Now it will act as a user as well. It will be like, I'm now the user as well. Let us check which particular step will the user take that will give him the best particular opportunity to win. So we'll do the exact same thing that we did downstairs once again, but this time it will act as the user. This time it will act as the user itself. Again, it will take up the position as -1. Again, it will take up the value as -2. Again, it will put up the I in range 0 to 9. Again, it will check whether the board is fill up or not. But this time, it will not put up the value 1. It will be putting up the value of the current player. It will not put up the value 1 because this time it does not know whether it is the user or it is the computer. So whatever is the current player, that particular value he'll be making it on the board. That is now what he is representing. Now, if it is currently the player is the user, it has to figure out the score as well. Now the score will depend upon which particular person who will take, if he is now the user, he has done a particular step. Who is the next particular person to run? What is the next step? What is the next particular? Who is going to put up the next step, guys? Could you guys let me know? If the AI is acting as the user, who is going to take up the next step after that? Computer, right? So instead of putting up -1, it will be player multiplied by -1. That will be the negation. That will be the other person itself, right? That will be giving us the score of the computer itself, right? It will give us the score of the user itself, right or wrong, guys? Please let me know. Again, it will be removing whatever step that it made. Again, it will be checking if the score is the highest or not. Right? But this time, instead of directly assigning that particular position is the position that it is going to choose, it cannot choose for the user. It cannot choose for the user itself. It cannot choose for the user. It can only choose for himself. That is why inside of computer's turn, the last particular step was to place what the computer wants to place it as. Here, it is going to check if after all this particular thing itself, if the POS, that is the position, still comes out to be equal to -1. That is the last particular step, guys, wherein there's nothing left on the entire board. It did it for the user, it did it for himself once again, then it again did for the user, it did it for himself. All the possible scenarios itself, it checked for itself. What was the last particular case in which there are no other places to fill, right? There's no other places, all the places that's already checked. That is the end goal, right? That I've put up my X and zeros at all the different boxes itself. That is the end goal right over there, right, guys? In that particular scenario, it's a draw. If somebody won, then we are returning who won right over here. If nobody is winning, if it's a draw, in the case that all the boxes have been filled up, there are two possible scenarios of the end tree. Either somebody is winning or it's a draw. If somebody is winning, then we are returning who is winning. If it is a draw, that means all the boxes gets filled up. All the boxes get filled up. In that particular case, what will you be returning? In the case of a draw, what value should you be returning, guys? Please let me know. If it is a draw, what value should you be returning? 0. Because it's a draw. It's a fucking draw. You cannot return anything. Otherwise, return the last value of the tree. I want to propagate the node values. You want to take it up further, right? Calculate which particular position was the best. That is the value that we are trying to propagate further, right? The last particular step is return value. Because this is a min-max algorithm. You want to propagate the value of the end nodes. Whatever the value is, it is 0, it is somebody winning, whatever the case is, that will be propagated further upwards. That is the thing that you will be putting up at the very end of this code. And that is how you have now written the entire code of an AI. Let us check if it is working or not, or else we will have to go through every single line of code, figure out what mistakes I've done up till this point of time. Let us hope that we have not done any mistakes. The only thing that we can do is hope for it, right? There's nothing else that we can do for it. Main function, that is the function that is going to execute our entire code itself. Let us run that. Let us choose that we want to play for a single player itself. We want to play as the first player itself. Where should we put our X, guys? Where should we put our X? X is the us. Where should we put our X, guys? Please let me know. Put it up at position 5. Great. So the AI has put up its 0 at the 0th index. Where should we put up our next particular X, guys? Where should I put up my next particular X, guys? Three. Where should I put up my next particular X, guys? 3. It has put an O right over here. So the only possible output that we are having is we have to put our X right over here. That is at 1, 2, 3, 4. We don't have any other option. We have to put it up at 4 itself. Now, what are the other options that are available to us, guys? Where should I put my X? Now, it is also a draw. So no matter where I put it up, there's nothing that I can do about it. Let us put it up at 2. And we have to put it up at 9. And at the end of the things, guys, we have got an AI that will either draw us or win against us. Let us give it a chance to win as well. Let us give it a chance to win. Let us see if it tries to win or not. Okay, let's do the exact same steps, guys. Single player will play second. Okay, will not play first. We'll give it a chance. Let us put up an O at the first particular index, guys. Let's put up our X at the third particular index. We'll put up our x at the uh, seventh index, guys? Oh shit. No matter what we do, it has won. So our AI has beaten us to our own game as well, guys. No matter if I put my X right over here or here, it will win. Let us see if it wins or not. Let us put up our X at the index 9, guys. And our AI has won. So we have coded finally, after all this things that we have done, guys. We have finally coded an AI against which, as a human, I can never win. I can either be a draw or either the AI can win, guys. Finally, after spending 8 days without knowing Python, without knowing what is AI. Okay, so Siddhartha has said one thing. Siddhartha, sir, in this session, you have only explained about code, but not about concepts related to artificial intelligence. Even you have prepared notes for us to say, but you didn't. Siddhartha, again, just to explain the facts to you guys, on the third day and the fourth day of this class, this is the eighth day, I've already explained what is min-max algorithm, how to use it, what's the intuition behind it, what is artificial intelligence, what is machine learning, what is data science, what is the difference between the same as well. Siddhartha, coming to 2 classes or 3 classes, you will not be able to understand what I'm teaching. That is the reason why the boot camp is of 8 days. If you are coming every single day, you will be able to understand what I'm teaching. If you're coming for 1 or 2 days, you're not practicing things properly, you're not learning what I'm teaching right over there, you're not focusing upon the class, you won't be able to understand anything. I'm so sorry, Siddhartha, but for that, you have to attend all the 8 classes. What I'm going to do, I'm not going to provide you guys with the code. Okay? What I'm going to do it for you guys is I'm going to scroll through the entire code itself. Okay, I'm going to scroll right now through the entire code. Providing you guys with the code is of no use to me. Okay, I will provide it to you guys at a later point of time, but right now I'll provide you guys with just a scroll of it that you can refer to this particular video and do it yourself as well. I'm scrolling it slowly and steadily so that you guys are able to go through it. Please make sure the number of spaces that I put, it is very important in Python. If you're not following the spaces, your code will not be able to run properly itself. Okay. Let's run it once again. Somebody said 5, 3, and 6. Let's try to do that as well. First player, 5, 3, and then 6. But if I put 6, then it is able to directly win right over there. Somebody said 5, 3, and 6. If I put 6 right now, O has already won. Because then this will be in one line itself. Try it out, guys. Whatever you guys are saying, try it out. Okay, you will never win against it. Okay. Somebody said 5, 3, and 6, and you will win. You cannot win. If you have written the code properly, you cannot win it at any particular point of time. Okay. Okay. The next thing for all the students, okay, there are two things that I want you guys to let you guys understand. Attendance is compulsory for all days to get the certificates. Now, I'm going to share with you the project submission link. For those guys who are coming to the class but not listening to me carefully, they think that, array, attendance I will get and I will get the certificates. A googly for you guys that I will be having one more class tomorrow. The last class will be there tomorrow, guys. Okay? Are you guys able to understand this? Tomorrow will be the last class that is there. And end note for the class, today I'm not taking any attendance. Okay. Tomorrow's class will be having your final attendance. Today there will be no attendance. Tomorrow's class will be your final attendance, guys. That will be your final attendance for this boot camp. Okay. 8:45 the boot camp will start. That will be the final boot camp itself, guys. So it won't be of 1 hour. It will be a smaller class itself. Okay. So if you guys are there filling up your attendance, we'll see what happens. And from tomorrow, from 6 o'clock itself, from 6 to 7:30 every single day, we'll be starting out with our career counseling sessions as well. Are you guys able to understand it? Every single day. So I'll be taking up career counseling sessions for the next 3 days continuously. Okay. If you are attending the career counseling session, I will be taking up another attendance on the basis of just that attendance. Even if you don't have 7 days of attendance, even if you don't have like 100% of the attendance as well in the boot camp, if you're attending the career counseling session, you'll be able to get the Microsoft certificate for the boot camp directly. We're editing the session and filling up the attendance of the career counseling session itself. So tomorrow, 6 to 7:30 for the next 3 to 4 days, you have to attend just one session. You don't have to attend all the sessions. You have to attend just one of the career counseling sessions itself. Okay. That way you will be able to get your Amazon certificate guaranteed no matter how much attendance you are having the boot camp. In the career counseling sessions, it will be a Zoom session itself. It will not be on like YouTube. Okay, you will be able to interact with me. The main aim of the session is to help you guys answer your questions related to your career paths, what you're currently pursuing, how it is going to go on and so forth. Okay. The career counseling session, you have to be a part of the WhatsApp groups that are links that I've already provided to you guys. Okay. If you are the part of a WhatsApp group, please do circulate the link for the group itself with your own peers, with your own friends as well. So that as many students, see, I want to make sure that I want people to know that just studying HTML, CSS, JavaScript, just studying Python, just studying a little bit, one project of AI and Python is not going to get you any jobs or any internships. No company is looking for just this is just the basics that is there. I'm just touching upon the cream itself. There's a lot that you have to study. I've already told you guys in AI you have to study data science, data analytics, data engineering. So all these things I want as many people, okay, as many people to know about it. Okay, so you have to join just one of the career counseling sessions that is going to happen in the next 3 days itself. Okay, the next 3 days itself, guys. Today there will be no attendance. The career counseling session is there in the WhatsApp groups itself, guys. If you guys are not the part of the WhatsApp group, I will provide you guys the link to the WhatsApp groups as well. No issues in that. Again, for the third time in my life, I will provide you guys with the WhatsApp group link as well. Give me a second. Let me check how many participants are there in the group because I have to check that as well. Give me a second, guys. Give me a second, guys. So this is the link to the WhatsApp group, guys. If you guys want, circulate the link with your peers, with your friends as well. Ask them to participate in the session as well. They will also get the certificate for Amazon for being a part of the career counseling session. Okay, and you guys will also get it because you will be, if you guys are attending it, you don't have to attend all the 3 sessions. You just have to attend one of the sessions, guys. Okay, you don't have to attend all the 3 sessions. You just have to attend the only one of the sessions itself. Okay, so make sure that you attend the session. I've provided you guys with the WhatsApp group as well. Today there will be no attendance. Tomorrow we'll be having our last class at 8:45, and we'll be taking up our last attendance right over there. I just wanted you guys to thank you guys that you guys have been there with us from the start to the end. Okay, a lot of things that you guys have done right over here, and let's make sure that this remains a success. Make the project, and always remember, the more that you code, the better you will become at coding. The more that you practice, the better you will be at it. And at the end of the day, that is what is going to get you guys the best placements out there. Okay, thank you so much, guys. It was great meeting you guys. For those who are asking about the project, dude, what are you doing for the last 8 days? For the last 8 days, I'm explaining you guys the project itself, right? So yeah, thank you so much, guys. Have a great day about it. Okay, and those who are asking about the project itself, dude, come on, man. For the 8 days, whatever project that I'm doing, if you guys are asking me what is the project, then I'm so sorry I cannot help you guys out. Okay, thank you so much, guys, and we will meet in the career counseling session, right? Thank you so much, guys. Thank you, guys. Thank you. Bye, guys. Bye.